What is RF channel simulation? My name is Michael, and I'm going to answer that question with a 4-minute demonstration of the RT Logic channel simulator. Channel simulation is the process of modifying an RF signal in a way that gives it characteristics of a signal that has actually traveled through space and time between 2 points. So, in the example we're seeing here, we're playing a video on the left. That video is being transmitted through a modem, received by a second modem, and then we're displaying the output of that second modem here on the right. So the transmitted signal, the received signal. In the lab, of course, this equipment is separated by several inches. You can imagine in a realistic SATCOM scenario, the link between these devices may be tens of thousands of miles. So using the RT Logic channel simulator in between the two modems, we can actually distort the signal in a way that models what would actually be happening in this satellite communication scenario we're watching. So there are 5 key effects that are critical to creating a realistic simulation of a channel. Number 1, Doppler Shift. As the transmitter and receiver are in motion relative to one another, the frequency changes. So this is both the carrier Doppler shift that shifts the entire frequency left and right in the spectrum, and also a signal Doppler shift that compresses and expands the carrier, effectively modifying the amount of bandwidth available for those signals. Number 2 is delay. As a signal travels from point A to B, of course, it takes time for it to get there. In a geosynchronous satellite scenario, this is on the order of 250 milliseconds, and this constantly changes as the transmitter and receiver move relative to one another. Number 3, path loss. The power level received on one end is not the same as the power level transmitted on the other end due to free space loss, atmospheric effects, and multipath effects. Number 4, noise. Any antenna that's tracking a signal is also receiving ambient noise from several sources, and this effectively degrades the power level received by the receive end. And finally, interference. In today's very crowded frequency spectrum, interference from other signal sources is a constant concern and has to be accounted for in the design of that satellite system. So what we're watching here is a scenario where AGI's STK software is controlling the RT Logic channel simulator in real time. And what you'll see is the transmitted and received signal are nearly identical because there's great signal strength, as you can see here on the built-in signal generator inside our system. So what I'm going to do so that we can visually see the effects of some of these distortions is play a different scenario that first ramps down the power level significantly over time. And so what you can see is the received signal now is distorted. It's not matching what was transmitted because, as you'll see, the power level is quite low compared to its maximum. As the power level ramps back up, the modem comes back into lock, the signal quality is restored to its original. Secondly, we'll ramp up the noise level in the system. So you'll see here the noise floor in the spectrum is rising, and again, as it increases, the received signal in fact locks up altogether as the modem can't track. As it drops back down, the signal received will again match the signal that was transmitted, and again the quality of the data goes back up. And finally, I'll inject several interfering signals underneath our primary carrier, and it distorts the data again. The quality of service is significantly degraded. So the RT Logic channel simulator provides a realistic way to test RF communication equipment, be that modems, transmitters, receivers, software, firmware, and this can all be done in the lab before flying a mission. So if you'd like more information, visit our website at rtlogic.com, and thanks for watching.